Oh, God. Of course I get the heavy side.
This is a simplified overview of how the jet engine works. Air first goes into the compressor, compresses, goes into the combustor, and fuel is added to the mixture. After it combusts, the exhaust gases drive the turbine, and then the spinning turbine shaft then translates into the compressor spinning.
Alright, we got power.
Oh, you got it.
You got it?
Yeah.
Good.
Here's a diagram of a typical combustion chamber inside of a turbojet engine. Each one of these tubes is called a combustor, and together, all the tubes together are called the combustion chamber. The main purpose of the combustion chamber is to mix the compressed air with the fuel and to contain the combustion process.
I'm tight in this.
Turn the wrong way.
The first zone, with the smallest holes, is to let a certain amount of air in and mix with the fuel, and this is where ignition takes place. The second zone allows a little bit more air than the first zone in, and allows for any unburned fuel to complete in combustion. Then the third zone, which is called the Tertiary Zone, lets a large amount of bypass air in to cool the products before they travel to the turbine.
How do you decide on the thickness of the chamber? Should you do a pressure vessel wall calculation? Are there tables you consult that says for this much combustion, so much thickness has to be there, or?
We basically went off the output of the compressor and multiplied it by 3. We actually asked Dr. Rooney for a pressure vessel calculation because we were a little bit rusty.
Yeah, that way.
Righty tatty, lefty
Righty tatty.
Is it open? This is embarrassing.
How did you decide how much space to leave between the outer shell and the inner shell? Of
The air gap?
Yeah.
Well, we were really concerned about adequate cooling, as Yakov said. So having a sufficient air gap we felt was important because the amount of air entering the engine would be a high amount. So we wanted to provide enough air for the room for the air to circulate around the flame tube. This is what introduces the air into the engine.
Explain to everybody why you need to start the engine with an external,
Air supply is to spin up the turbocharger beforehand, because once it starts spinning, when it ignites, it will want to spin in that direction, it won't want to spin in the reverse direction. Okay, so 5, 4, 3, go Thomas, 2, 1.
I think Jordan asked a question during the video of why you guys are close to it. So can you explain to Jordan that, I think a lot of people don't understand that.
To have the engine already spinning, it's kind of like a boost, to get the turbo going, get the whole system flowing, get air flowing through the engine, mixing with the fuel, which is also important. You need to have air traveling through the engine for a successful ignition. So open the tank all the way, the left one. Just open that. Now turn the regulator. There we go. Yes.
How did you figure out what the pattern of holes should be on the inner chamber?
Well, here's the thing. We did a lot of research, and we were looking at, I showed you that picture of the combustor tube, and the pattern of holes wasn't really important. It's really, what's important is the size of them and the placement.
More or less?
Lower.
Less?
Lower.
More?
Lower.
No, less? Lower?
The problem we had was we did not wait for the engine to reach a self-sustaining RPM in which you could pull the air source off and the compressor can successfully supply enough air to maintain combustion. So the way we figured out to solve this problem is to turn up the throttle much more than what I did in that video so the engine can reach a self-sustaining RPM.